So, shall we start?
Yes.
Yes, let's start. Okay. Two more words about the stretch, because I have forgotten to tell you that this functionality works also the best with some other functionality from SQL 16, which is called temporal tables. Temporal tables means that we have a pair of tables. One table, it's I call it base table. It has one version of each row. And if you change the row, if you add new row, a historical version is being created in the temporal part. And now you can imagine that that part here is your base table, and you can stretch the temporal part to Azure. So you can have a historical version of your rows that are constantly loaded to Azure. And this is also very nice that those two features can work together. It did not work in CTP older than 3.3, but starting from 3.3 it works. Okay, now we should go to the query store. It's called by Microsoft as flight data recorder for your database. The most exciting feature, I think, from my perspective as a DBA, that's something I really want, and I wanted it from long time. So imagine a situation, we all face it almost every day, that if the application is not working, for example, website is down, so the first approach from our end user or customer is that the database is not working. And probably it's even right. The database might not be working for some reason. For example, it could be a problem with the database, but the most probable thing is that the query has some regression. So a new plan was generated, and the query uses a new plan, which might not be very good, might not be optimal, and the query is very slow. Right now, the query cache we have, the query cache stores only one version of plan. I mean, it could be two plans, one for parallel execution, one for serial. But for a single query, we basically have the latest plan. We do not have historical information how the plan changed during the query execution in time. So we have problems with finding plan regression. We also trying to find why the query is slow, when it became to be slow, and what was the previous query plan. So we have a long time to detect. And also the third part, which is maybe not so obvious, but if we deploy a new service pack or cumulative update, or maybe even a new version of the product, our query might go, the execution time might go up, and the query is getting slower because of this migration. In the service pack and in the full version of products, we can have optimizer changes, we can have optimizer patches. So query that performed well, suddenly after the service pack stops working very good, and we have to find out why. So we have a very big, we have many types of problems, and it can be very difficult to find out what is the real problem, what is the real issue. And for example, we would like to have the opportunity to compare how the query behaved historically and how it behaves right now. And to solve the problem, Microsoft proposed to use a query store. And the good information is that this functionality will be in all editions. I'm not sure if in Express edition, because Express is, for learning, but also in standard edition, query store will be present. Which I'm not sure about StretchDB and temporal. It's not yet known, but for sure query store will be in all editions. So we have a dedicated store that will capture every historical plan for each query, we have to turn it on per database. So we have a database, we have to turn it on, and the query store tries to capture all historical plans for us. The data from the historical plans are stored on disk. So every time you restart the server or restart the service, you do upgrade and recompile, every change is also persisted on disk. So we have the history. That's done. Yes?
Is it saved in the database that comes in your backup?
Yes, it is. I show you because I already restored my database. So in that case, probably we have more opportunity to lower down these times, time to detect and time to migrate, because we will find very easily the queries that has the regressions. I hope so, at least. And what is more important, we will be able to force plans, the historical plans, to our queries. We still can do this because there is something which is called plan guide, but it's not that obvious and not everybody can do this, and probably no one does it, telling the truth. Right now, this is because Connor, yes, he's the guy, yes. Okay, it works in the same way, like you said. It's also Connor's statement that this functionality, when you try to force the plan, it works that way that when the query is executed, then there is a SQL statement, use plan and plan number from this. It works exactly the same way. I like you were using plan guides, but the plan guide is applied automatically. So you see the statement here, the DBA is now in control. Okay, how it works. This is the query store. It's per database. So in each database, you can turn it on or off. By default, it's of course turned off. You have to do it. It must be your decision to turn it on. Every time a query is compiled, a plan is cached by SQL Server, and it's stored in this plan store within query store. Then when the query is executed, this runtime information about, for example, session settings, so this execution context is also stored regarding to this query. So right now we see we have this static information about queries, about their plans and runtime stats. And based on this, we have information, we have statistical information, how our query behaves from different point of view. We have new dynamic views here, and we can control some other options. I mean, how often this data has to be, for example, flushed to disk. What is the interval when we would like to analyze the query? I will show you in a moment how it works. That's basically the same picture. However, there is a word async, means that those informations are kept in memory, and in some period of times there is a background worker that stores the information on disk. So we have the information stored in the database. This query store is always stored in our primary file group. The initial size is 100 megabytes. It could be more or less if you wish. The interval of sending data to disk is set to 15 minutes right now, and it could degrade your performance on about 3%, 3 to 5%. Remember about this. The faster you would like to store the information on disk, I mean in shorter interval, the performance will be lower because your SQL Server will be working on saving data on disk. Okay, we have views that expose information from this internal tables for us. So we will be querying query store views, and those views always take information from memory part and from disk part, and the views do it automatically. We don't have to change anything. We see always the latest data from the view. There will be, as you can see, 6 types of views. One which is called query text, which stores query text information. So select from, etc. will be in the view. And one distinction, do you know right now that there is a view query stats that gives you information about query plan from the cache? This view operates on batch level, and query store operates on statement level. It's a little bit more granular because batch can contain many statements. Statement is the lowest granularity we can have, and query store operates on it. So this is the query text. This is the query you would like to run. Select from star. Then there is a context setting information. So the session settings, for example, the language, the date format, etc. Then we have really the query, because we have a query that is running under these settings. So we have another view that combines those two information. Then we have plan from this query, from these settings. And this is the static part. And then we have runtime information. So how this plan was used, what was some runtime's values. For example, average time, how many cores were involved from the processor involved to run this query. How much memory was granted, how much memory was used. Everything what we have to know. How much rows were sent as the result, because sometimes maybe the query just return one row, and from the next execution it could return millions of rows, and the plan can be different, should be different at least. The last view is called runtime stats interval, which describes the interval in which statistics are being kept. For example, this interval can be 15 minutes, can be 1 hour, can be month, and you can run statistics on that interval. For example, do average on this interval smaller or larger, depending of the setting of the settings. Those things are of course configurable. Okay, I already explained that. Okay, internal tables, and we have views. As I explained, query store is the functionality, query text is the first block, settings, context settings, then a query, which is here, and a plan, and runtime stats. You will see it on the demos in a moment. And this is a real scenario when you can use query store from the beginning. So the migration to SQL Server, the newest version, 2016, and there is always a problem when we should change the database compatibility level to the newest version. For example, we have SQL Server 2012 or 2014. We have database created in that server, and we would like to move the database to the newest version. When we should change this compatibility level, because it could happen then when we change it, we will see the performance degradation. It happened in the past, especially in 2005. But probably you remember then that in 2014, there is a new optimizer written. So we had some performance degradation on some queries, not on all, but I saw it. So how should we do this migration using query store? First of all, we should install new SQL Server, and we should not change this compatibility level of our database. So we have new SQL Server, we attach database, and then we run query store on that database, and we run our queries. In that case, we have baseline, our baseline, how the database behaves on the old compatibility level. Then we change the compatibility level to the newest number. It's 130 right now, and we have this query store running. We run the queries again, and we see if the performance is degraded or not. If yes, then we can force the plan as if the query were running the old compatibility level. So we have query store now working on new SQL Server database. So we have fixed regression on that queries that really needed that by forcing a plan. Okay. There is a graphical interface, so rich set of reports where you can analyze the queries. So a lot of metrics I will show you. Then we can, for example, compare plans. You see for the selected query, the green one, we had 4 plans. We can always compare those plans, how they to compare among them, and we can choose the one that we think that it's the best one in our case. We have to make, as administrator, we have to make this decision. So what should we do? First, we have to alter our database. So we have to turn the query store on. That's the first part. We can review the parameters of the query store from the database query store options. Of course, we can not only turn it on like this, but also we can change all the properties by using transact SQL statement. You can always clear the query store if you think that you don't need it, or maybe you would like to capture the data one more time, and we can turn it off. It was a question if the query store is included in the backup. Yes, it is. So if you restore the database in new place, you have all old historical information from the query store with you. The query store also works on the read-only databases. Means you can do select, you can choose plans, but you cannot generate new plans in that case. And then if you don't like the reporting tool that Microsoft provided, but I think it's actually very good and from visual point of view really can help you, then you can write your views to display relevant information. I will show you some views I already found to show you how to work. But at the end, you can also do forcing your plan. So, for example, for query number 12, use plan 14. You will see this information in the reporting tool, or you can read it from the catalog views. So we have both new catalog views and some new store procedures to handle the query store. At the end, there is also a very nice feature which is called live query statistics. You can observe query plan on real time. So if you have a big query that is running, you can turn on live query statistics, and you will see how the data is flowing on which operator. It really enables you to concentrate which operator takes too much time, for example, because you see that this operator is stopping data flow, for example. I try to show this also to you at the end. And right now, let's go to the demo. I think it's the right time to do the demos. Query store. Where is the query store? Let me disconnect from Azure. So, database, properties, and you see here the last option is called query store. And we have some information that are configurable. The first one is operation mode. How the query store will work. Read-write means that it will capture new data. Read-only means that it will not capture new data, only historical, what is already there. And off means that you are going to turn it off. Data flush interval 15 minutes means that every 15 minutes data from memory will be sent to disk. Remember, don't make the time lower because the performance can be hit by that. Statistic collection interval 5 minutes right now, so we collect this information in 5 minutes block. What is the maximum size of the store? Right now it's 1 gigabyte. What is the capture mode? Says all. All means that every query will be captured. If you choose auto, the last option here, that means that if the query is not relevant, if it is run only once, or the execution time is very, very slow, it will be automatically dropped from the query store as irrelevant. because we would like to conserve this space. It's right now it's 1 gigabyte. Size-based cleanup mode. What does it mean? What happened if the query store is almost full? We have to do something with the space. So if you choose auto, that means that if you are above 90%, then some old or less relevant queries and those informations will be cleaned from the query store, and the size will be set to approximately 80%. So only 10% of the data will be cleaned. But of course, you can say that you would like to clean, and then you can set the base cleanup mode to off. But I recommend to set it to on. And how much days data should be stored in the query store? In my query store, it's 31 days, but it's also configurable. We have two graphs here. The first one is about the database. How big is the database? My database, this AdventureWorks, is around 0.5 gigabyte. And you see that the query store, that's the line, it uses right now only 1 megabyte from my database. So it's not big. Okay, the same you can do from the Transact SQL. So you see, I described you the operation from user interface, and you see by which command you can do the same in Transact SQL. So for example, we can alter database and set the query store properties like I described it on the screen right now. If we are ready, we can turn the query store on by this statement. If you wish, we can clear the query store or we can turn it off. But right now I have some historical data in the query store, so I don't want to clear it or I don't want to turn it off. But I want to clean my procedure cache with plans, and I would like to show you a stored procedure, which is very simple. This is the query that will be running, and you see the procedure is really very simple because there are two tables that are joined: product and transaction history. We have a join predicate on product ID, and we'll be searching products by this expression. So I will be sending a parameter name like letters ABC, and then I'm concatenating with %sign. So that's the idea. There is already a project. Okay, the procedure is already there. So I'm going to clean the procedure cache, and this procedure will be run million times to see how the plan is changed. And there is an algorithm which works from this number 1 to million, and when actual number of parameter is divided by 100 with no reminder, so the parameter that is sent to the procedure is M. In other case, it's letter from B to H. So you see that in this case, I will have small subset of products. In that case, I should have many products returned by the store procedure. Okay, that's the first execution here. And there is more. I am generating a random number. So it will be basically a number between 1 and 100. If the generated number is less than 3, so 3% of cases, I'm clearing the cache. And if this number is divided by 2 without reminder, so the parameters is from A to Z, so basically everything what I can imagine. Otherwise, this parameter is O, and I am running the procedure. The goal is to have different plans for the query. So I try to run it. Hopefully it will not kill the management studio, but we see. So it's running right now. You see it's operating. I have some results from my queries. And now I would like to see this query store information. Under AdventureWorks, there is new folder which is called Query Store. If it is disabled on the database, you will not see it. But in this database, I have it enabled. We have 4 reports right now that are in the box. Regressed queries, overall resource consumption, top resource consuming queries, and tracked queries. I start with top resource consuming queries. And you see, this is my query. Very simple optimization in that case, yes, in this database, because nothing else is running. So it's very simple. We see that it runs for a minute, and we have 3 plans already on the right here. Plan number 2, plan number 3, and plan number 4. And of course, those plans are not optimal because you see that some index is missing. But one of those plans, plan number 4 in that case, uses parallelism, so it's parallel plan. Some other plans, like plan number 2, is not it's serial plan. It just scans these 2 tables, uses hash match. The other plan using hash match plus stream aggregate to prepare this grouping part. So we can find which plan can be optimal, because this is the according to the metrics here, this is the duration. So this is the duration because my metrics that was chosen was duration. You can find another ones very useful. For example, logical reads, logical writes not in that case, but memory consumption or physical reads. So if you think that there is a problems with your disks somehow, so then you can choose the physical reads as a metric of the statistics, and then you can choose what is the statistics, for example, average, maximum, minimum, standard deviation. Standard deviation would be useful when your query returns, let's say, 1 row and million rows. So there is a big standard deviation for this query, or a total in that case. Okay, we have some buttons here. The first one refreshes is for refresh. Remember that if you run refresh on the left pane, it refreshes all grids. If you do the refresh on the right pane here, it just refreshes the right part because it's context information. So if I selected my query, there is another button which called track the selected query. It's exactly this report. So I can track the query. So you see that there is a new report. Opened, and you see the plans that were generated during the query execution, because the query is right now executed in background. So you see that one of this circle is small and one of the circle is bigger. That means that using this plan here at this moment of time, it was small execution count. It's bigger execution count, because the size, if it is bigger, means the query was executed with this plan much more times. So in that case, I would choose that plan as the optimal one. How to do it? I can select this plan, and you see that there is an option to force it. Of course, we can always do a plan comparison, for example, so we can compare plans. So all plans that were generated, you can see them in a moment. It should be displayed here. I hope so. Okay, 1 we have, 2 more to go. And right now, it's up to you to decide which one to choose. You can pick that one, basing on your knowledge. If you decided that, for example, that one is the best, so you can just do a force plan. You have to confirm. Okay, action done. And right now, if I could refresh this information, should be refreshed. Let's do it manually. You see that one plan that will be displayed here. Oh, we have plan number 4. But you see that that one is ticked. That means that you forced that plan to use it. It was your decision and you forced that plan, and the query is now running with this plan. So many more options here. You can play with this. you can, for example, check about your queries regression. So do you have some queries that are really regressed? I show you in a moment how the regression is constructed, but you can also configure every of this report can be configured on your own. And for example, there are some information. So we'd like to make the comparison based on duration and total, and what is the time interval on the report. This is recent is last hour, and the historical is last week. You can change it, and 25 queries are taken into consideration in that case. So lots of opportunities for you as administrator to right now to optimize your queries. At the end, I would like to show you, I'm going to close that, but I would like to show you the views. So what can you do with your with the query store? First of all, we have database query store options. So those are just options of the query store. So that's the configuration. Query store text, it was the first block on the slide on the left. So those are just the text of the queries that you submitted to the database. So you see I have a lot of them. It's 65 because those views, I mean those query is also captured there somewhere. I mean this query text. Then we have query context settings. And you see there that it's easy to, for example, read date format and date first, so we know which date is first, and the language ID, but the set options are not so easy to decode. You have to do it on your own, and I should have some information for you how to do this. So you can join views like query stored query plus dmexec query stats, and then you will have this query plan handle. You can copy this plan handle there, and there is a view which is called dmexec plan attribute, which decodes this this set options. Okay, maybe this is not something that you do every day, but it's good to know that it's possible to do this. So one more time, some of the context options are easy to read. Come on, this, and this. So language, date format, date first, but this you have to decode on your own. At least I shown you how to do this. Then we have select this query store query. So query store query is context plus query text. So you see it how they are combined. So the first three columns, we have query ID, we have query text plus context. And if you see that object ID is not null, that means that this query is kept and is stored in stored procedure. Anything else, that can be ad hoc queries, like probably I do right now. So I have only one stored procedure that is right now running in the other window, and the query is the query number 2. So we can go even to this query store text, and you see that this is exactly in query number 2. This is exactly what we should have there. This is the query from the store procedure. Okay, let's go down. This is how to find objects from that are from stored procedures, for example. In this this view has the last compile has the plan stored in query plan column. I'm trying to find it. It's somewhere there. But the problem is that you cannot click it. So, but if you cast the column as XML, then at the end, as the last column, you will see that the plan is. You saw it here. This is the query plan, but you cannot. It's not too easy. You have to copy it to other window. But if you do the cast like this, So you can just click it and you see what was the query plan. So it's only for this purpose. I did it that way. So I introduced new column to be able to click on it. Then we have this interval view, which describes the intervals, and because the view has to know, the next view, the runtime stats, has to know how to calculate the statistical metrics. That's why we need the start time, end time to be able to do groupings on query information, query runtime information. So that's the final view. And we have everything we need. We have to join to all other views to find out what was the plan, what was the interval. From plan we can go to context and to query text at the end, but see what kind of information we have. You see how many times, for example, your query was executed. In my case, there is a query that was executed for the given interval 109 times. You see average duration, last duration, minimum plus maximum duration, plus the standard deviation. So you can see for example, the regression. Something was executed in that time, and then it was executed in one much longer. So we see that it could be a problem there. Average CPU time. So for CPU, for also for I/O information, the same set of information for reads and writes, and also for CLR time. If you use a CLR store procedure, for example, it's also important. Information about if the query was done in serial or parallel, because we can have such situation, and about memory. So how much memory was granted, how much memory was used. Then, having this information, for example, you can create your own reports. For example, 10 last queries that were run on the database. So you see you have them all 10. Or very easily 5 to find, for example, 10 most expensive queries based on average runtime. Just by combining those views that's exposed by the query store. Of course, you can find also the execution plan. Do we have query plans? Do we have query that were run in parallel, for example? The last view, which is called runtime stats, has a column which is last DOP. I pointed that column to you a moment ago. So very easy to find, because nothing right now. Parsing XML problem, because probably there is some problem there with this. I should comment it out, and in that case it could work probably like this. It should be not a problem right now. At least we have some information. So we have some average duration plus the query text at the end. So just by manipulating this view, we have complete overview what is going on with the system. We can easily find queries, execution count per a query. So if we have queries that are executed very frequently, you can do some parameterization. For example, list of the queries that has longest execution time in a given period of time. For example, I introduced a variable which is called hours. So I will be analyzing queries in this time period. So in the last 12 hours, what was the most queries that has longest execution time? And it's up to you. What would you like to find? I will pass you all the views I found already, and maybe that will be useful. And this is something. This is all I wanted to show you right now. It should be now question time, but we do not have time right now for question because you have the break, and I know that the break is also very important. So you can drop me an email if you have any question later, or if you forget, Johan can send me your question. So thank you for attending this afternoon with me. Thank you for being here. Once again, do not forget about this conference. I would love to see you in Wrocław in 3 months. Thank you. And have a nice evening.